Welcome to CS 288, Module 4. We're going to go over Chapter 5 in this module, the Introduction to DNS in Windows Server 2008. So our objectives will be discussing the basics of DNS and its terminology, configuring DNS clients, installing a standard DNS server, and create standard DNS zones. DNS, a primary function is to translate human-readable host names. Assist the flow of email, provides mail exchanger records that tell a simple an SMTP server where to send an email message. Supported on the internet by thousands of distributed servers or DNS servers. Here's some of the terminology: DNS namespace, DNS domain, fully qualified domain name, hosts, hostname, DNS record, and DNS zone. So we'll go into each one of these. A DNS namespace is organized into the following domains: the root domain, or the top level, secondary domain, and subdomain. I'll show you an example of this coming up. DNS domain, the portion of the namespace to the right of the host name. So when we talk about DNS names, we go from the right to the left, as opposed to the usual way where we go from left to right when we say we read a book. Fully qualified domain names, the entire name for a specific host that needs to have a DNS record created. So that's going to have the name of the computer, the name of the domain, and then the top level domain, which is either .com, .local, etc. So that makes up a fully qualified DNS or domain name, which is an FQDN. So let's look at the top level. So a top level domain can be .com, which is the most common, .edu, .gov, .net, .mil for military, .org, all these different types of things are all top-level domains. In our particular case, we have a second-level domain we're calling BenTech for some of our labs. So the BenTech part is the second-level domain. So again, we started at the right, which is at the top level. Now we're going to the left, and then we go to the third part, which is the subdomain. In this particular case, it could be www, it could be mail, it could be SMTP, it could be web, whatever it is you want it to be. We no longer need www in an address anymore, but some websites, of course, still use that. So you don't have to go to a subdomain. You could stop right at the second level domain. You could stop at bentech.net and be perfectly fine. But if you wanted to have subdomains, you could have subdomains as far back as you would like to make them, and you'd be able to reach those. So some of the terminology is hosts, a computer on the internet that provides a specific resource. So a host is, of course, any server or computer. A host name is the name given to that computer or host to make connecting to it easier. Such as in your office, you may want to connect to your server. The server may be called Server 1. So Server 1 is the host name. The fully qualified name of that particular host name might be server1.yourcompany.local. But you only have to put in Server 1. You don't have to know its IP address. You don't have to know anything else other than just the name. A DNS zone is a collection of connected nodes served by an authoritative DNS server. So if your particular domain is bentech.local and you have a zone in your DNS server called bentech.local, then you are authoritative for that particular domain name. And then the DNS records are the records to provide information that it stores, such as the mail server might be mail.bentech.local, and that would be a record in the DNS Manager. So now let's talk about queries. There are a couple of different types here. We've got iterative queries and recursive queries. An iterative query is a DNS client requests the best answer that its DNS server can provide. So if, for instance, you don't know the exact name of something, you could put in something close to it, and it will try to find the best answer for you, typically done by the DNS server itself. A recursive query is a little different. It says, hey, I know exactly the name I'm looking for. Return that name exactly back to me as I ask for it. So it either will and return it to you, or it won't and it will error. So let's take a look at a DNS server in sort of an overhead view. You've got ns1.widgets.local here, and then you've got a client side, which is client1.widgets.local. So what's made up of this particular DNS server is the root name server, the .NET name server, the bentech.net name server, and the web1.bentech.net. So these are all different types of records, DNS records, that are sitting inside this one DNS server, DNS zone. DNS clients, often referred to as DNS resolvers. A Windows Server 2008 uses the DNS client service to perform DNS queries on behalf of the client. So that server actually goes out and finds all that information out for you, and they can automatically register those host names into the DNS zone. If it cannot find it, or you want to manually add it, you can add a static record. But otherwise, the DNS server is going to go and find them for you. DNS servers, for a client to resolve DNS queries, it needs to know which server to contact. So you have to have in your IP information, you have to have the name, or the IP address of the server it needs to go to find all this resolution. The first one in the list is called the preferred DNS server. DNS suffix, the DNS domain appended to all unqualified name queries. So as we talked about earlier with server 1, all you have to do is put in server 1. It automatically appends the bentech.local. You don't have to type that in because the DNS Manager automatically appends that for you. So if we take a look at a typical TCP/IP4 property page, you'll see that there is a preferred DNS server. And then you'll see there's an alternate DNS server. Now you can see that this preferred DNS server is the internal IP address server, and the alternate is a public one. You don't want to do that. You want to only have internal DNS servers listed in your properties. The public DNS servers get put into DNS Manager in what's called forwarders. I will show you that in a little bit. So if we see adding a DNS server, we can do it through the netsh command. Netsh interface IP set the DNS for the local area connection. That's the name of the network card. Static, and here's the IP address. So that's how you would do it with a command line, but we're going to do it through the GUI as well. All right, installing the DNS server. It is a role that can be installed on Windows Server 2008 full and server core version. Doesn't matter which one, you can make it a DNS server. If it's an Active Directory domain controller, then it will by default check the box to add itself as a DNS server. If it's not a domain controller, then you can just manually add it. A caching-only DNS server, you may see this show up on one of your tests. It is a server that has the DNS role installed, but it has no DNS zones installed with it. So it's not authoritative for anything. So basically it just caches information. For instance, if you go out to various different websites such as Yahoo, CNN, Google, and you go through your internal DNS caching only server, then it will cache that information. So the next time you go to those websites, instead of going out to the internet, it will look to the local DNS server and it will resolve it much more quickly. By default, all DNS servers are cache-only servers, but if you decide to have one without any kind of zones on it, you can certainly do that. Root hints provide IP address pointers to top-level DNS servers. A lot of people don't realize this, but the entire world runs on 13 top-level DNS servers in various government and university locations. If all those servers go down, the whole internet goes down. So you'll see sometimes a denial of service attack that's pointed against one or more of those top-level DNS servers, and that brings down the internet for a big chunk of the world. When configured, a DNS server can perform queries when it receives DNS domain name requests for zones in which it is not authoritative. So if I make a request for yahoo.com, but I'm not authoritative for it, of course I'm not, then my server will forward that request out to the DNS server that is authoritative for it so I can get that resolution to happen. So it provides referral answers to queries in a DNS server's request to resolve an unknown domain name request. So that's basically what it does. It goes out and finds that information for me. Forwarders, as I mentioned, those are servers used to resolve names, and I'll show you an example of that. Zones, building blocks for creating your DNS infrastructure. By default, all Active Directory domain controllers that have DNS installed on them have the internal zone for that particular Active Directory domain. But you could also add zones for other domains if you want to redirect requests to other locations. For instance, you may not be authoritative for Facebook.com, but you don't want your users in your office to go there. So you can create a Facebook.com zone in your DNS server, point it to nothing, and then people will no longer be able to go out to Facebook inside your office. So that's one way to do content filtering. DNS zones are classified in 3 ways: the information they store, what kind of records they have in them, where they're stored, where's the location of them, and then whether they can be read-write or read-only status. And you do that by it's the type of zone creation that you create. You can create primary, secondary, and stub zones, which I'll show you in a minute. So zone.dns, that's used to store the records. This is typically in the C drive, Windows, System32 DNS folder. Anytime you see system root, that's what that means. It's the folder that contains the Windows installation. Bind is something that all DNS servers nowadays support, whether they be Windows, Unix, Linux, all different ones support bind. It's an industry standard which allows Windows and all other types of operating systems to communicate with each other. Primary DNS zone, the zone that is authoritative for a specific domain and its name records. By default, as I mentioned, the domain controller is authoritative for the internal Active Directory domain zone. A secondary zone, read-only version of the DNS records for a zone, and a stub zone, which is also a read-only copy. So why would you have a secondary zone as opposed to a stub zone? Well, a great example for this is the type of offices that you have. So let's say that your main office is in Portland, but you have a secondary office, an office that may be a smaller one, located in Gresham. So when that happens, you want to set up either a secondary zone or a stub zone on your DNS server in Gresham to point back to the primary zone in Portland. That way you get a read-only version of the copy. So if it gets updated in Portland, it pushes that update down to Gresham, but Gresham can't make any changes. So if you have a junior IT administrator there or no IT administrator, they can't end up messing anything up. Well, a secondary zone is used if you have a very slow internet connection. So it keeps an entire copy of all the zones or all the records in that zone in the Gresham DNS server. And since the changes don't happen very often, you have a slow internet connection, then it allows you to keep that full copy on to that server. If you have a lot of changes or you have a fast internet connection, you want to create a stub zone. A stub zone says, hey, you're in Gresham, you want to find server 1. The stub zone redirects the information back to the primary DNS zone for up to the minute information. So if you're changing servers all the time, have a lot of servers, and you have a fast internet connection, the stub zone is the way you want to go. If you have the opposite of that, then you want to go with a secondary zone, so you have an entire copy of all the information at your secondary site. A forward zone does a forward lookup for names to IP addresses. A reverse does the opposite. So I'll show you an example of that in a command prompt. So if we ping yahoo.com, this is a forward lookup. Now if we do a ping -a to the IP address, we do a reverse lookup. Uses the reverse lookup zone. So you see two different pieces of information. If we're pinging yahoo.com, it gives us this IP address. But if we ping -a, it gives us a different name. It's not just yahoo.com. You see all these subdomains that go with it. And the reason for that is because Yahoo is distributed among many locations. So when I go to yahoo.com from my location, it looks for whatever the closest web server is that's to my area, so I can get there in the least amount of time. So that's why you have a forward lookup zone and a reverse lookup zone. Information in a DNS record, you've got the serial number, the owner, the time to live, the start of authority. Those are all pieces of information that you'll see in a DNS record, and I'll show you that shortly. The name server record identifies the DNS server that is authoritative for that zone. So that's just the name of the server that you're going to be going to in order to do all this name resolution. So a host record is also called an A record. It provides host name to IP address resolution. So when I did the ping to Yahoo and it gave me this IP address, that is a forward lookup zone host record. AAAA records are for IP version 6. So it's the same thing except for it's version 6 instead of version 4. The MX record is used to specify a mail server. So sometimes you need to go into GoDaddy or Network Solutions and set up your mail record or your MX record. And that says, hey, if any email that needs to get delivered can be pointed to this location. Sometimes you need to create an MX record in your Windows DNS server. If for some reason you want to have a direct connection to a different IP address than what the internet is going to automatically send you to. So for instance, we have a customer who has an MX record set up, or two MX records set up. One is set up to one mail server and one is set up to the other mail server. Well, it turns out the second MX record is broken. It's pointing to a server that no longer exists. So some of our email gets delivered to the wrong server. And although we've contacted that company and said, hey, one of your MX records is broken, they don't believe me. They don't believe us. So we said, oh, well, no problem. We'll just create our own MX record and point it directly to the server that does work. And then we don't have that problem anymore. Alias records are used to create an alias for a specific host. So an alias record would be in case you have multiple names for a record. Say server 1 is the record, but I also want people to get to server 1 if they type in SMTP because it's our mail server as well. So that would be an alias to server 1. So that way you can have multiple names all point to the same location. Pointer records are the exact opposite of forward lookup. These are the reverse lookup records. They resolve IP address to hostname. So instead of hostnames to IP, it's IP to hostname. Service locator records provide the following information: location of services it needs, network protocol, domain services it provides, and extremely important in Active Directory. So you've got to have these service locator records in order to find where Active Directory is located and how to get access to its location. The master server provides updated DNS record information to secondary servers. So if you create that secondary zone or your stub zone, then whatever is the server that first starts that zone record, it's considered to be the master server. The slave server gets its updates from the master zone transfer. Now, we normally don't use master and slave anymore. We use primary and secondary, but you will occasionally see these types of things written in various different books and publications. Zone transfers from the master to the secondary server. In this case, they're mixing terminology here, master being master and secondary being slave. Server comes in two varieties: incremental zone transfers and full zone transfers. Full zone transfer happens less often than an incremental one. Secondary zone transfer partner and master zone transfer partner. Here they're mixing the terms again, but that's okay. You now know what they mean. Start of authority query from the secondary zone to the master or primary. Start of authority response, and then what type of query after that, and then its response as well. So that's how that works. And this would be either the full or the incremental transfer. So in summary, we talked about DNS, responsible for providing name resolution. If you have any kind of slowness on a network, that's the first place I go is DNS. It's 95% of all slowness in any server, network, or client. Core functionality of DNS to provide hostname to IP address resolution, standard zone classifications, primary, secondary, stub, and DNS uses many types of records to store its information in zones. Installing the role can be done through the server manager or through command prompt. And the DNS console is the main tool that you use to manage it. So let's take a look at a DNS manager right now on a server. And you can see we have 3 different DNS servers listed, and we have lots of different zones here. The .local zone is going to be the one that is going to be for some of the different Active Directory domains that are on here. .com zones are going to be ones that are being redirected, as I mentioned earlier, where we want things to go to a location manually. So you can see all these different records. These are all A records or host records. That's TCP/IP version 4 forward names to IP addresses. So if I double click on one of those, you can see the name, and you can see it's grayed out a little bit, but you can see the IP address. And there's some other ones, other zones as well. So you can see our name server record. This will basically show the name server that is doing the resolution. You can see the SOA record. If we can just click on that tab, and you can see the primary and the responsible person in charge here is in charge of that as well, which is the host master. That's just a default type of a thing. And you can also look at zone transfers as well. Do we want to allow zone transfers? By an Active Directory, it'll happen automatically. But if you want a zone transfer from a primary to a secondary, this is where you would set that up. So you would allow zone transfer to any server, or only servers that are listed in the name server tab over here. Or do you want to do ones that are listed in the following servers? So this allows the zone transfers to happen, so you can have those primary, secondary, or primary stub relationships for multiple offices. If we right-click on the zone and go to Properties, that's the exact same thing, place we just were, as if we double-clicked on any one of these records. Aging gives you an idea of how long that the record is good for before it gets renewed. And WINS allows you to tie to an older WINS database, which we don't do anymore. Now if we go to the server itself and go to Properties, we see different information, such as what IP addresses are going to respond to those DNS requests. We certainly don't want it responding to a 169 address. That's an APIPA address that goes nowhere. So what we do is we choose only the following addresses, and we check the IP4 and 6 addresses. So make sure you go in and do that in case you have multiple network adapters that are not being used, so that way they won't accidentally give the wrong response. Forwarders, this is, as I mentioned earlier, something that you would do to set up the public DNS forward requests. So if I am on a client and I want to get access to server 1, then it'll give me access to server 1. If I want to go to yahoo.com, then it'll say, hey, I don't have yahoo.com here, but I will forward it to these different IP addresses, and they will tell me where yahoo.com is. There's also an advanced section here. If you've got multiple DNS servers, you can enable round robin. You can also keep records from getting stale by being updated on a regular basis. The root hints, these are those servers, as I mentioned earlier, that run the internet for the whole world. And they will use these hints in case none of the forwarders that we set up are working properly. The other information here is security, monitoring, and logging, that kind of thing. And we won't go over those in this particular unit. So let's go over our lab. So our lab here today is on DNS. First thing we're going to do in this particular lab is we are going to disable IP version 6 so it doesn't cause us any conflicts, because we'll be working in version 4 in this particular lab. So go through the book and follow these instructions for capturing the different screenshots. And using the information I just gave you in this presentation should allow you to get through the lab, and you should have no issues. Otherwise, you can contact me for additional help.